Section 7.5 is called Strategy for Integration. So this section basically covers all the other sections that we did in the past, 7.1 to 7.4, with miscellaneous. So the author wanted you to know, if I give you a random integral, which method do you use to integrate it? Okay? And here what we did, we selected 8 miscellaneous questions with everyone given a chance to try it. And now we're going to go over them. So this is the first one. As some of you said, we can do this with the partial fraction decomposition. So the way I'm going to do this, I'm going to just drop the bounds for now, and then I can come back to it. So how do you do this? Because it's a partial fraction decomposition, we need to factor the denominator, x minus 5, x plus 1. Right, so x plus 5, x minus 5, x plus 1 equals a over x minus 5, b over x plus 1. Then we multiply everything by the LCD to give me x minus 1 equals a times x plus 1 plus b times x minus 5. So then we select values, say -1, that will give me -2 equals -6b. So b from here is 1/3. X equals 5. You get 6 equals 6a, so a is 1. So this was straightforward, partial fraction. Then that integral becomes a, which is 1 over x minus 5, b, 1/3 over x plus 1, dx. And that would give me natural log of the opposite value minus 1/3 natural log of the opposite value, right, plus c. Now, what we're going to do after this step is the bounds are 0 to 4. So we're going to do 0 to 4, x minus 1, x squared minus 4x minus 5 dx. So this is what we got, natural log of the first one minus 1/3 natural log of the second one from 0 to 4. Then we open 2 parentheses, one for the 4, one for the 0. Substitute the 4 in, natural log of -1, opposite value, 1/3 natural log of opposite value of 5 minus natural log of opposite value of -5, natural log of opposite value of 1. This is 0. This is 0. What do we get? -1/3 natural log of 5 minus natural log of 5. And if we combine both of them, we get -4/3 natural log of 5. That's the answer. So now we have the value of a here. When we plug the 5 in, that should be 4. So that would be 2/3. So we have 2/3, 2/3. So we get -3/3, just negative that. So it was the integral of sine cube x cosine cube x dx. So how do we do this? We are going to, because both have odd powers, the trick is you can save a copy of either sine or cosine. It doesn't matter which one. Let's say I want to save a copy of cosine, right? And then that will give us 2 copies left of cosine, like that. Then, so I saved a copy of cosine. I need to convert the remaining into sine by rewriting this as 1 minus sine squared x. Now we use the u sub, u equals sine x. du is cosine x dx. So this part is du. As you can see, it's very easy now. U to the third minus u to the fifth du. You get u to the fourth over 4, u to the sixth over 6 plus c. U is sine x. So replace the u with sine x to the fourth now. Number 3 says the integral of cosine squared 2x dx from 0 to pi. 0 to pi. So how do we do this? We start with recalling the formula for cosine squared x. It's 1 plus cosine 2x divided by 2. But the question said cosine squared 2x. So we can multiply the angles that I'm highlighting now with 2 to get cosine squared 2x equals 1 plus cosine 4x divided by 2. So then this becomes the integral 0 to pi 1 plus cosine 4x over 2 dx. We could pull the 1/2 out. The integral of 1 is x plus the integral of cosine 4x. It's 1/4 sine 4x from 0 to pi. Then we need to substitute the bounds. What are the bounds? So we open 2 parentheses. Substitute the pi, 1/4 sine 4 pi, minus the 0. So sine 0 is 0. Now, this gives us 1/2 pi. 4 pi, it goes back to 2 pi, to 0. And sine that is 0 as well. So the answer is just pi over 2. Number 4, this was given as number 4. Here, what we do, the u sub, u equals the cubic root of x, or you can write x to the 1/3. So du is going to be 1/3 u to the negative 2/3 du. Du x. So when you bring that down, it becomes x to the 2/3. Then du is 1/3. You can rewrite this, the cubic root of x squared dx. So here we need a 3 in the integral itself. We need a 3 down here and 3 up there. E to the u, all of this is du. 3e to the u. U is the cubic root of x. For the next one, number 5, we can rewrite it. Looks like 1. 1 is a sign for me that tells me, hey, maybe you can use tan inverse. So I rewrote the e to the 4x as e 2x squared. And then we can take u to be e to the 2x. So du is the derivative of this 2e2x dx. So I'm missing 2 on the top, so we're going to do 1/2 here and 2 on the top. Then keep the 1/2 out. The top is du, the bottom 1 plus u squared. That reminds me of a formula. 1/2 tan inverse of u plus c. But don't forget to replace the u with the x term, which is e to the 2x. Number 6, the integral of cosine x dx. For this one, u sub is not going to work, so we need to use integration by parts. So remember the trick LIATE. We have algebra and trig. So u would be the x, and dv would be the cosine x dx. So du is going to be dx, and v is the sine x. So then the formula says uv, if you want to write it down, uv minus the integral of v du, ux, v sine x, minus the integral of v sine x, du dx. So that gives us x sine x plus cosine x plus c. So there are many ways to do this one. The easy way is, as a trick, is to add ex on the top and subtract ex dx. Now this will allow us to group the first two terms and split it up. Ex 1 over 1 plus ex dx minus ex dx. So the first one will go just 1 dx. And this one could be integrated using u sub. U equals 1 plus ex. Du is ex dx. So it's going to be integral of du over u, which is absolute natural log of absolute value of u. So natural log of absolute value 1 plus ex plus c. Now one thing here important to know is the absolute value is not needed here. Why? Because ex is always positive, plus 1 is always positive. So this quantity, we know it's always positive, so it's no need to put an absolute value there. Second method, the second method is basically, let me write it down first. So we can take u to equal 1 plus ex. So du is ex dx. But we don't have a dx there on the top. We don't have ex. So then du is, we can solve for ex, which is u minus 1, and then divide by that for dx, if you want to put that in. So the denominator is u, and instead of dx, we're going to put du over u minus 1. Now we got a new integral where it looks like we have to do partial fraction decomposition. So how do we go about this? We start with 1 over u times u minus 1. It's a over u, b over u minus 1. Multiply everything by the common denominator. A times u minus 1, b times u. If we take u equals 0, what do we get? A negative 1. And if you take u1, you get b1. So we found a and b. Now we can move on and integrate. A is negative 1 over u, b is 1 over u minus 1, du. So that's negative natural log of absolute value of u plus natural log of u minus 1. don't forget the plus c. Again, we're going to go back and see what was u. U was 1 plus ex. So we're going to replace that. 1 plus ex plus natural log 1 plus ex minus 1. For here, these cancel out. Natural log of e to the x is x. So this is x. And here we can drop the absolute value. And if you like to rearrange it so it matches the previous answer, or the previous method's answer, you put the x first minus natural log of 1 plus ex plus c. Before we do number 8, we are going to look at the integral. Last time we showed you how to prove the integral of secant x. It was natural log of absolute value secant plus tan. Okay, that's what we did last time. Now, how about cosecant x? You know, what is that going to be? There's many ways to prove this. Maybe you can multiply the top and bottom by, if you multiply it by cosecant plus cotan, or cosecant minus cotan. So let's see if we multiply by cosecant minus cotan. Let's see what happens. Dx. On the top, we get cosecant square x minus cosecant x cotan x over cosecant x minus cotan x dx. Right. Then u is what? What is u here? U is the denominator. Du would be, what's the derivative of cosecant? Is negative cosecant cotan minus derivative of cotan is negative cosecant squared. So it becomes positive. And don't forget the dx. So then this on the top, I got du. This whole thing is du. On the bottom, u. So that gives me natural log of absolute value of u plus c. Then in return, it's cosecant x minus cotan x plus c. That's for cosecant. Okay, that's for cosecant. 8 was the integral of the square root of 1 plus x squared over x dx. So one thing comes to mind is trig substitution. About trig substitution, x equals tangent 1 tangent. Now we can it doesn't have a formula. Or 1 plus sine squared, no formula. Only for 1 plus tan squared. And then as we always did in trig sub, we have 3 things to find here. First one is dx, which is secant squared theta d theta. Next one, 1 plus x squared. So 1 plus tangent squared. And now you know 1 plus tan squared is secant squared, which comes outside as secant theta. And for the last step, we solve for tan theta. Tangent theta is x, or x over 1. We draw the right triangle. This is theta. Tangent is opposite over adjacent. So the hypotenuse, by the Pythagorean theorem, it's the square root of 1 plus x squared. Now we go back to the integral. The square root, I simplified it to secant theta. And x in the bottom is tan theta. Dx is secant squared theta d theta. Now, sometimes, you know, maybe I tried to do it in the morning in my head and I just replace everything or convert everything from sine into sine and cosine, right? And I'll show you, maybe we can take it from there to something else. But let's try to finish it by keeping this the same and replace secant squared with 1 plus tan squared. could split this up, secant theta. If you multiply this out, 1 plus tan squared theta over tan, rearrange it. We can split this up into 1 over tan theta plus tangent squared over tangent is just tangent, d theta. Now you can distribute. So you get secant theta over tan theta, d theta plus secant tan. So secant tan, we know a formula for that, which we're okay with it. The only thing left to do is take care of the first part. If we happen that we need to convert things, that's when you're stuck on the integrals for trig. Convert things into sine and cosine. So secant is 1 over cosine. Tangent, sine over cosine. Sine theta over cosine theta, d theta. And let's keep the last one the same for now. So then this becomes, the cosine would cancel. You get 1 over sine theta. That's cosecant theta. Let's keep the last one the same. Then we just proved the formula for this. Natural log of the opposite value of cosecant theta minus cotan theta plus this one is secant theta plus c. But it shouldn't be done yet because we need to, the problem start with x, we need to get everything back to x, right? So we can go back and replace each one of them. So from the triangle we had, this is the triangle. I can redraw it here. We don't have to scroll back and forth. Opposite over adjacent, and this is the hypotenuse. Natural log. So this one, cosecant is the reciprocal of sine. Sine opposite over hypotenuse. So that would be hypotenuse over opposite. Cotan, reciprocal of tan. Tan is opposite over adjacent. So adjacent over opposite. Plus secant, reciprocal of cosine. Cosine, adjacent over the hypotenuse. So it becomes the hypotenuse over adjacent plus c. And here we combine the fractions by having the common denominator. So if we go back to this circled one, let me rewrite it down there. Okay, we have secant cube theta over tan theta d theta. So let's say someone decide to do, convert things into sine and cosine. So 1 over cosine cube over sine over cosine d theta. Then the cosine goes on the top. Here we have sine theta cosine cube theta d theta, which can be reduced down to 1 over sine theta cosine squared theta. Okay? Now, if you try to take u equals cosine, it's not going to work. U equals sine is not going to work. But there's a smart way here we can do to this one. Watch what we're going to do. Keep denominator the same. So I'm going to multiply top and bottom by sine theta. So that makes this square. Why did I do that? Because I'm going to convert this into 1 minus cosine squared theta. Keep that the same. Keep this the same. D theta. And now I can take u equals cosine theta. So du is negative sine theta d theta, which we have it on the top. So we need a negative, negative. So that gives me negative du over u squared times 1 minus u squared. Oh, what does that remind us about? partial fraction decomposition. So now we can keep, we're going to go on the side and factor this one out first and write it as a over u plus b over u squared plus c over 1 minus u plus d over 1 plus u. You can try it on the side as you did in pre-calc, and then you will get that a is 0, b 1, c negative 1/2, and d 1/2. I know you like that, and you know it takes time at home to do it, which is okay. So the integral of the first one, a is 0, it's gone. B is 1, so 1 over u squared du. C is negative 1/2, so negative 1 over 2, 1 minus u du, plus 1/2. Oh, we don't have an integral there. 1/2, 1 plus u du. Close the bracket. This one you can move it up du, pull the 1/2 out, and notice you can swap this, swap it, make it positive. Instead of 1 minus u, make it u minus 1. And then pull the 1/2 out, du over 1, u plus 1. Ready to be integrated, u to the negative 1 over negative 1, 1/2 natural log of this, 1/2 natural log of that. You know, you can put the plus c later. And then, you know, you substitute the u back in, and, you know, after the u, you go back until you get to the x. Easy? And